Johnson's rule problems always involve two stages of work. Even if pristine aircraft maintenance had not mentioned Johnson's rule, we could still recognize it as a Johnson's rule problem. Let's take a look. Pristine Aircraft has received 4 Boeing 737 airplanes that require maintenance. Airplane SW1023 will require 4 days of hull inspection and 3 days of painting. This is what I mean by 2 stages of work. Airplane DL040 will require 1 day of hull inspection and 4 days of painting. Airplane SA009 will require 5 days of hull inspection and 1 day of painting, and airplane AA887 will require 5 days of hull inspection and 5 days of painting. Hull inspection must always be completed before painting can begin. Assume that pristine aircraft uses Johnson's rule. It does mention Johnson's rule by name to minimize the overall amount of time needed for maintenance on these 3 planes. Now, how are we to recognize that this was a Johnson's rule problem if it hadn't said Johnson's rule? First off, the 2 stages of work, in this case hull inspection and painting. Also, there's a series of jobs. The issue is just what order to do them in, given that there's 2 stages of work, and the last feature, just like it said here, hull inspection always becomes before painting. There has to be a certain order. Okay, now, first question. In what order will they complete these jobs? In order to, use Johnson's rule to figure out the sequence that minimizes the overall make span, or the overall amount of time it takes to get all of the jobs done. Oh, okay, now wait a minute. The best way to tackle this particular problem is to take this information first and set it up as a table. A lot of times with a Johnson's rule problem, the table will already be there, but notice we just have an anecdote, a paragraph. Not a problem. I'm just getting organized. Hull inspection, painting. These are the 2 work centers, the 2 phases, the 2-step process that's mentioned in this problem. There are a series of jobs. It's the airplanes. SW023, what does it say? 4 days of hull inspection, 4, and 3 days of painting, 3. I'm just copying this information down table style. Okay, airplane DL040, 1 day of hull inspection, 4 days of painting. Airplane SA009, 5 days of hull inspection and 1 day of painting. And then finally, airplane AA887. Ooh, that takes a lot of work. 5 days of hull inspection and 5 days of painting. Haven't determined anything new here, have just organized the information into a table. Because it's asking us to use Johnson's rule. Okay, in the case of Johnson's rule, the best thing to do next is to create a blank sequence, because what we're going to determine is what order those airplanes should be worked on. Okay, so first off, just denote the order. One of them is going to be first. One of them is going to be second, one of them is going to be third, and one of them is going to be fourth. I'm just creating blanks. Because now I'm going to employ so-called Johnson's rule to fill in the blanks. Now, how do you employ Johnson's rule? It's the look for the smallest number rule. Look at your data, and that's why it's helpful to have it organized in a table, and look for the smallest number. Now, on this data, I see a 1, but I see it in 2 different places. I see a 1, for instance, for the DL airplane, it's in hull inspection, and a 1, for instance, under painting for the SA airplane. I can select either of them. Because if I select the DL airplane, so to speak, that 1 is in the first column. That means that airplane should be scheduled first. And you say, yeah, but wait a minute, what if you happen to have selected the other one? That one, the other 1, occurs in the second workstation, which means that that job should be scheduled last. All right, so I'm just going to, you could pick either way. I'm going to pick the first one. I'm going to pick DL040. That 1 occurs at the first workstation. DL140 should go to the front of the sequence. It should get worked on first. Oh, now what? Cross it off the list lightly. So it's crossed off. Who's next? Well, you're still looking for the smallest number, and you see now the other 1 comes up. The other 1 comes up. It occurs at the second workstation. That means that that job should be scheduled last. That's how Johnson's rule works. Find the smallest number. If it's in the first column, push it to the front of the sequence. If it's in the second column, push it all the way to the back of the sequence. Say, okay, now what? Now cross it off the list. Try to cross it a little bit more neatly. There we go. Now, of the numbers that are left, find the smallest number. Okay, well, of the numbers that are left now, the smallest number belongs to SW. It is in the second column, this 3 that I have found. That means that this job, in this case this airplane, should go as far to the back of the sequence as possible. And right now that's 3rd place. It can't go all the way to the back of the sequence because that's already occupied. We already booked that slot, so to speak. So it goes as far to the back of the sequence as possible. Mark it off the list. Well, there's only 1 other airplane left over, then it's going to go in the 1 other blank. There's our sequence. In order to get the hull inspection and painting completed for this group of airplanes as fast as possible, this is the order that pristine aircraft maintenance should work on those aircraft. Now, with Johnson's rule, that's pretty typical. You notice how a lot of the times what the way that the sequence develops is it basically develops from the ends, front and back, and works its way in towards the center. But it really depends on just the data that you're working with. Okay, anyway, that was the first question. What else do they want to know about this? When should pristine aircraft tell each airplane owner that the airplane will be completed and available for flying? Oh, we need to know the flow time of each aircraft. The flow time of each aircraft, when each aircraft here is a job, when each aircraft will actually be finished. The best way to answer that is to take our sequence, now we know what the sequence is, and to draw a Gantt chart. The Gantt chart will reveal that. And you can see that if you have the note frame, just for convenience, there is an empty grid here to start on a Gantt chart. Now we have 2 work centers. One of them is hull inspection. I'm just writing hull. And one of them is painting. Just for short, I'm writing painting. This is a timeline in a Gantt chart. Okay, this is a timeline in a Gantt chart. They're talking about days worth of work. So we have a blank Gantt chart for what? There's 3 days, 4, end of the 5th day, 6, 7, 8, 9, 10, 11, 12, 13, 14 days, 15 days, 16. I don't know if it's going to take that long. 17, 18, 19. Oh, this is this blank grid represents 20 days worth of work. Okay, now we want to basically illustrate the sequence that we found in the first part of the problem. Okay, so that sequence is that aircraft DL040 should be done first, worked on first. I'm looking at the lightly crossed off data. It's 1 day worth of hull inspection and 4 days worth of painting. I just want to represent that on the Gantt chart. I say, oh, all right, well, if we work on it first, that means this would be the hull inspection. I'm just coloring in, I'm reserving 1 day, and then 4 days worth of painting. 1, 2, 3, 4. 4 days worth of painting. The painting cannot start until the hull inspection finishes. That means down here in the paint center, all of this first day is going to be idle. They're going to be waiting for the aircraft that begins with DL. to finish up in hull inspection. Now I'm just marking our bookings, so to speak. There we go. We have booked in the first aircraft. Okay, we've booked in the first aircraft, and actually at this point, if you were in a hurry, like that aircraft's owner was on the phone, you could answer the questions posed above for that first aircraft, because the question is asking when will they be done, and you can see that for the first aircraft, DL040, I am noting when the painting finishes up right there at the end of the 5th day, so essentially in 5 days. In 5 days, the aircraft will be ready. All right, now we want to determine this for each aircraft in the group, so we have to keep booking time essentially on the Gantt chart. All right, now if we're following the sequence, who's second? Second in the sequence, AA887. All right, I'm looking at the data. Ooh, that's a big job. 5 days of hull inspection, 5 days of painting. All right, well, if it's done second, that means that hull inspection can start here on the second day, and I want to reserve 5 days. 1, 2, 3, there's 3 days worth of hull inspection, 4 days worth of hull inspection, 5 days worth of hull inspection. Okay, and that is all for that big job aircraft AA. Now, this is hull inspection. When hull inspection finishes, that's when painting can start. So I need to be careful that painting starts at the correct time, right here at the end of the 6th day, the start of the 7th day, and then from here is where I book 5 days worth of painting. 5 days in the paint shop for that aircraft, AA. That means this awkward little gap in here is just exactly that. It's an awkward little gap. It is what we call forced idle time at the paint shop. It represents the 6th day of this schedule in which the paint shop is idle because it's finished up on the first aircraft, but it's still waiting for hull inspection to finish up with the next aircraft. Oh, okay. Now, right. And if you tried to work this problem before and you got the sequence correct, but you didn't get the flow time answers correct, chances are you have a problem in here where maybe you scheduled AA to start paint too early. So just keep an eye out for that. Anyway, we can see the flow time now for this aircraft because we can see when it will finish. It will finish there at the end of the 11th day, so we can note that to the side. Aircraft AA887 will be ready in 11 days. Okay, then who's next? We consult the sequence SW023. That aircraft is next. That is 4 days worth of hull inspection and 3 days worth of painting. 4 days worth of hull inspection. 1, 2, 3, 4. Okay, so this is for the third aircraft, SW. And it will finish up right there at the end of the 10th day in 10 days. It can't proceed immediately to the paint shop because the paint shop is still busy with the aircraft before, but that's not a problem. The 3 days of painting, we will just start them as soon as we can. So we're essentially booking this time here for SW. Oh, and we can see the flow time then for that aircraft. That will finish in 14 days. SW023, 14 days. And then finally, to finish off this entire sequence, who's last? In last place is SA009. All right, what's the data? 5 days worth of hull inspection, a lot of hull inspection, and 1 day worth of painting. Okay, 5 days worth of hull inspection. 1, 2, 3, 4, 5. That's all hull inspection for the last one in the sequence, SA, which means that painting can't start until the 16th day. So here is that 1 day of painting. Apparently this aircraft didn't require a lot of painting being finished up. With this awkward little gap in here, here's a little bit more forced idle. right in here, and then we can see the flow time for that, 16 days. Okay, so to complete this summary report down here, SA009 is ending in 16 days. It will be ready in 16 days. They can pick it up in 16 days. Oh, all right, so that finishes that part of the problem. What's the last question? When will pristine aircraft maintenance be finished with all the work described in this scenario? Oh, that's easy. Well, it's easy now that we've done this other work with the flow times, because when will they be finished with all these aircraft? Good vocabulary term, also known as the make span of the project. Well, that would be when they finished with the last aircraft in that group. That was, and the only thing we need to do is just look at the most right-hand point right here in the Gantt chart. That's 16 days. In 16 days, they will have finished with SA0093, the last aircraft in the sequence. So it will take them 16 days to complete the work on this group of aircraft.